Welcome to Study Loop.
So I have made an equivalent circuit to that given in the book. So I have replaced the earthing and V with a cell of 36 volts, right? It is the same. Now the question is asking us to calculate the potential difference VAB. That is the potential of point A related to point B when the switch S is open. Now when the switch S is open, so no current flows through this 3 ohm resistor. So it seems like there is nothing in the middle, right? So there are only 6, 3, 6, 3. These four resistors are only available to take the current that comes out from 36 volts. Now, as the current goes out from the voltage 36 volts, so it sees that there are two branches. One branch has 6 and 3 in series, other branch also has 6 and 3 in series, right? So both of them have equal resistance. So both of them, that is the point, this point here, this point and this point will also have the same, I mean the 36 volts of EMF, right? And in between here, there is the ratio of resistance is 1 is to 2. So the ratio of voltage uh, across these resistance should also be 1 is to 2. So the voltage, if we want to divide 36 volts in a ratio of 1 is to 2, then this should 23 ohms should get, of course, 12 volts, and the 6 ohm resistor should get 24 volts, so that the total voltage is 36 volt, and the ratio of voltage is same as the ratio of resistance, that is 1 is to 2. Similarly, for the 6 ohm, the voltage should be how much? Since the ratio is 2 is to 1, so this should be 24 volts, and this should have, the 3 ohms should have 12 volts, right? Okay. Okay, now if you look in the figure, so this point here has 36 volts and 12 volt in between here. So this should be at a potential of 24 volts. So this should, point B should be at a potential of 24 volts, and similarly point A should be at a potential of 12 volts, because 36 minus 24 is 12, because this point has 36 volts and in between the 24 voltage is dropped. So what reaches here? 12 volts, right? Now if you want to find out VAB, so this should be voltage of A minus voltage of B. So what is VA? That is 12, and what is B? That is 24. So this gives me minus 12 volts. We are done when the switch is open. Now when the switch is closed, so let me close the switch here. I can just connect one line here. Okay, now the switch is closed, right? So when the switch is closed, now we can just give some current, right? So let us suppose that current I comes from here, from the battery, and suppose I1 goes along this way, and I might, whatever we did so far does not have anything to do now. Okay, the voltage that we have written is of no use now, because that was when the switch was open. Now since the switch is closed, we can just neglect those. Now current I gets divided into two, I1 and I minus I1. Now as I1 comes here, so let us consider I1 also gets divided again further into two, that is I2 flows across the 3 ohm resistor and the switch, and suppose this in this way, there is I1 minus I2, of course, right? So and since I2 gets here, I gets here, sorry, I minus I1 gets here, so these two, I minus I1 and I2, combine to give the current across the 6 ohm. So this should be how much? I minus I1 plus I2. Okay, so we have written all the currents flowing through the circuit. Now let us see the loops here. So the first loop that I would want to see is okay, let me see the question what it is asking. Okay, what is the current through the S when it is closed? Okay, to find the current we need to look at the Kirchhoff's loops here. So first let us look with the uh, with the bigger loop here that contains 36 volts. So let me draw the loop here this way, right? Okay, now there is only one battery here, that is 36 volts. So on the left hand side we write the batteries 36. Now this should be equal to the potential is dropped across 3 ohm resistor and 6 ohm resistor. So this should be I minus I1 times 3, and along the 6 ohm resistor that is I minus I1 plus I2 times 6, right? Okay, now this is equation first. We can further simplify this and write equation 1. So 36 equals to 9I minus 9I1 plus 6I2. Okay, let us consider this to be equation 1. Now let us look at the another loop, this one. Let me draw this in green, that makes it easier. Okay, this inner loop, the top left loop. So for this loop there is no any potential drop, so 0 in the left hand side. Now having the right hand side, I1 is the one that flows along 6 ohm, so I1 times 6. Now along 3 ohm, that is I2, so I2 times 3, and there is 3 ohm and the current is opposite to the loop, so minus of I minus I1 times 3, right? So let me write this in a simpler form. 0 equals to, in terms of I, this is minus 3I. Now I1 has the coefficient of 9 I1 plus 3 I2. Let me mark this as equation 2. Okay, now for the third equation, the circuit, the loop that I want to look upon is the bigger one. Okay, so I want to look over this loop here that goes starts all along the outer border of the circuit. So this is the third loop, loop 3. This is the loop 1, and this is the loop 2. Okay, now for the third loop, what we can see is there is only one potential, that is 36, right? And the drops are along the 6 ohm resistor, 3 ohm resistors, only that much. So for the 6 ohm resistor, that is I1 is flowing and it is along the loop, so 6 times I1, right? And for the 3 ohm resistor, it is I1 minus I2, so that is also along the loop, so plus 3 times I1 minus I2, right? Okay, let me write this in simpler form. 36 equals to 0I, right? And there is 9 in the coefficient of I1, and for I2 there is minus 3 I2. So this is the third equation. Now just look at where we have reached. We have now 3 equations and 3 variables I1 and I2. So the physics is finished. Now just go through the mathematics to solve these 3 equations. Then you get I equal to 8.57 amperes. Similarly, I1 equals to 3.43 amperes and I2 equals to minus 1.71 ampere. So the minus sign indicates that the supposition, the assumption of our direction of I2 was the opposite. Okay. So according to the question, we are asked to calculate the current flowing through S. So the current flowing through S is I2, and that is equal to this way 1.71 ampere, right? So this gives me the solution to part B of the question. So this was part A. Now this whole can be for part B. Now for part C, we are asked to calculate the equivalent resistance. Well, it's very easy now. The equivalent resistance is what determines the current, right? So there is a 36-volt battery. The current I, we have current I. So this I depends upon the equivalent resistance of the circuit. So equivalent resistance Req equals to the battery's voltage upon the current. We can consider that the internal resistance is 0 because nothing has been said probably about this, right? Okay, so we don't need to care about the internal resistance of the battery. So voltage is 36. Now the current that passes through the battery is 8.57. So if you divide this comes out to be 4.2 ohms. Hence, we also found out the resistance of the equivalent resistance of the circuit, and hence this is the solution to this question. Thank you for watching.